Hi guys, hope everything's going well so far. So this is going to be a little checkpoint and debrief on what we've learned up to this point. So in the last POGIL, you learned about percent composition. And so we've talked about percent composition a little bit in terms of what it ultimately represents of the compound. And so really it's just taking the portion of the compound. So if we were to look at, for example, dihydrogen monoxide, water, and wanted to know the percent composition of hydrogen within it, we would just take we would first need to know what the entire mass is, the entire molar mass. So we'd start off by finding H2, which we know that from our periodic table that hydrogen is a molar mass of 1. And so H2, so you take 1 times 2, and that's 1 gram per mole times 2 because there's 2 hydrogens. We have 2 grams per mole for the hydrogen, and then 1 oxygen, which is 16 grams per mole. And adding that together, the molar mass of water is 18 grams per mole. And so then if we took the percent composition of the hydrogen within water, you would take 2 divided by 18, and then you're going to get a fraction. So then you would multiply that by 100%. So one tool I want to quick show you that will be beneficial, and I'll link this to our teams as well, is this online scientific calculator. And so what I like about it is that it has the E button down here, the double uppercase E's. This is representing times 10 to the. So if we did Avogadro's number, which is a mole, 6.02 times 10 to the, and then 23rd. And that E represents the times 10 to the, and then the exponent, and you would then see it as the value. So that will become very beneficial later as we continue with stoichiometric conversions. But I just wanted to bring your attention to that. So for this particular case, though, it's just a generic function of 2 divided by 18, and it's 0.11 times 100, obviously then becomes 11.11%. Okay, and so if you were to do it the other way, the oxygen then should then make up the other 97.89%, or I guess 98.89%, to make a total of, 89. There we go, Mrs. Ayler, of the entire amount, 88.89. So that's percent composition. The entire thing should equal to 100%. The next part is empirical formulas. So I want to bring us back to our POGIL just to review this. So empirical formula is kind of a unique thing where it's ultimately just showing us the simplest whole number ratio of all of the elements that are in a compound. And the reason this is important is because a lot of times as chemists, when we're starting to identify new substances, we do not get the information back of oh, it's H2O or it's H2O2. We get the simplest whole number ratio, and then from there we're able to convert it to the molecular formula based off the overall weight. And so we need to know the steps of how to calculate empirical formula. And your POGIL does a really nice job of outlining this, but to make sure that we are understanding the steps, I have a problem here that we are going to work through together. So, let's see, here we are. What is the empirical formula of a compound whose percent composition by mass is 50.4% carbon, 15.2% hydrogen, and 34.4% oxygen? So if we go back to the initial problem, what we would do is we would start with each of those percentages and divide them by the masses for those elements. I am getting the alert that this is going to end in 20 seconds, so we'll do another link here in the second video.